Okay, the next part is about knowing your cards, knowing your playing cards. And in the Western playing cards, you have 52 of them, and you have four suits. You have 13 hearts. You have 13 diamonds. You have 13 spades, and you have 13 clubs. Club sort of looks a bit like that. And the looking at every one of these suits, each one of these is called a suit. Uh, the hearts and the diamonds are red, so I'll get my red out. These are both red, and the the clubs and the spades they're both black, so I'll leave them black. So using this knowledge, then, what is the probability that you take a random card out that's going to be red? Well, out in total, how many red cards do you have? Well, you've got 13 here and 13 here, so you would have 26 that are red, and out of 52, that simplifies to a half. Now, you could have just seen that it's a half because half of them are red. When it's asking for a probability, you could leave it as a fraction or you could leave it as a decimal. I prefer fractions because if it was 2/7, for example, you couldn't really write it as a decimal very easily. So I tend to write them as fractions more often than not. For B, it's asking for a queen. Now, let's investigate this a little bit more. In every one of these suits, you have one of each number. You have a 1, 2, 3, all the way up to 13. But the 1 is not called a 1, it's called an ace. And then the next is the 2, the 3, the 4, and that goes all the way up to the 10. Instead of an 11, you have what's called a jack. Instead of the 12, you have what's called a queen. And instead of a 13, you have what's called a king. So the queen is one of these 13 cards. And each one of these suits has a queen in it. So the total probability of pulling a queen, you have one queen from the hearts, one queen from the diamonds, one queen from the spades, and one queen from the clubs. So that is 4 different queens out of 52. And again, this simplifies to 1 out of 13. For C, the probability of getting an ace would be the same as probability of getting a queen. There is one ace in every suit. But here it's asking for a red ace. And there are only 2 red aces. So it's going to be 2 out of 52, which would become 1 out of 26. That can't be simplified anymore. For D, the probability of getting the 7 of hearts, well, there's only one 7 of hearts. So the probability of that is just going to be 1 out of 52, and that can't be simplified. What about the final one, the probability of getting an even number? So this is a little bit trickier because your numbers stop after 10. These are not numbers, they're just letters, really. There's a jack, or it's also called a knave, a queen, or a king. So getting an even number, you could get a 2, a 4, a 6, an 8, or a 10. So there's 1, 2, 3, 4, 5 evens from each suit, but there are 4 suits. So in total, how many evens would there be? There's 20 evens. And how many cards are there? 52. So the probability would be 20 out of 52. Now you can cancel this down, you don't have to. And in probability, it's advisable to leave it like this actually. It's advisable not to simplify them because if you accidentally mess it up, then you lose a mark. But you don't lose a mark if you leave it in this form. So I'm going to just leave it like that actually. My answer is there.